11.7, perimeters and areas of similar figures. When two figures like these two triangles below are similar, the value of the ratio of their perimeters is equal to the value of the ratio of their corresponding side lengths. So if we found this triangle to be the red one, to have a perimeter of, let's say, 10, and the perimeter of the blue one was 20, then the value of their ratio is going to be 1/2. That's for perimeter. Now the same should hold true for the value of the ratio of their corresponding side lengths. So if AB length was 2, and we found then that we measured DE and we found that it was 4, we would see then that their value of their ratio of the side lengths is also 1/2, which matches the value, the ratio of their perimeters. Okay. So looking at this problem here, we want to find the value of the ratio, red to blue, meaning we want the red on top, the blue on bottom. Okay, so the value of the ratio of the red to blue of the perimeters of the similar rectangles. So if we we want to find the value of the ratios of the perimeter. So the perimeter of the red over the perimeter of the blue is the same as the value of the ratios of the side lengths. So the red triangle being 4 on top, the corresponding side length on the blue figure is 6. We can simplify that down to be 2/3. So the value of the ratio of the perimeters of these two triangles that are similar is 2/3. Okay, now when we talk about areas of similar figures, when two figures are similar, the value of the ratio of their areas is equal to the square of the value of the ratio of their corresponding sides. So if we took the area of triangle A and put it over the area of triangle, we'll call this triangle A, and we'll call this triangle X over triangle X, that should be equal to taking this side length, we'll call it 1, we'll call this 2, right? But squared. What's 1/2 times 1/2? That's 1/4. So the value of the ratio of their areas of the red to blue is equal to 1/4, which is squaring the value of the ratio of their corresponding side lengths. But let's try a problem. So here we have two triangles. We want to find the value of the ratio of the red to blue of the areas. So we need to look at the side lengths, right? Remember they said the value of the ratio of the side lengths squared should equal or will equal the value of the ratio of the areas. We'll say area of the red, area of the blue. Okay, but what does this simplify down to? This also becomes 3/5 squared. So this actually then becomes 9/25, because 3 times 3 is 9 and 5 times 5 is 25. Okay, now it is time for you to write in your notes. There are just a few fill in the blanks to do. And now time to do the 2 practice problems. Okay, so looking at problem number 1, it says the height of a figure A, I'm just guessing what the figure looks like, is 9 feet. And the height of a similar figure, figure B, is 15 feet. Okay, and they're asking us, what is the value of the ratio of the perimeter of A to B? Okay, remember perimeter, value of the ratio of the perimeter is the same as the value of the ratio of the sides. So A, we're given the height of 9. B, we're given the height of 15. We can simplify that down, and that gives you the value of the ratios, value of the ratio of the perimeters of the 2 figures. Okay, now for, practice problem number 1 again. We have the base of a triangle P is 8, and the base of a similar triangle Q is 7. What is the value of the ratio of the area of P to the area of Q? Now remember, when we're talking about area, we are talking about the square of the value of the ratio of the side lengths. So we have the base of P, which is 8, the base of Q, which is 7, but we want this squared. And what is that? And that is your answer. Okay, that is it for 11.7.